Next is sharing of capacitors. Sharing of capacitors. We are going to share two capacitors. Let us take capacitor C1, charge V1, voltage V1, charge Q1, capacitance C2, charge Q2, V2, voltage V2. The energy initially, charge initially is Q1 is C1 V1, charge initially in this is Q2 is equal to C2 V2, energy in this is half C1 V1 square, energy in this is half C2 V2 square. Initial energy thus is half C1 V1 square plus half C2 V2 square total energy. Now we are going to connect these two capacitors in parallel. The moment you connect, the charge tend to flow from a higher potential to a lower potential. Suppose this is Q1 V1 and Q2 V2, capacitance C1 C2, V1 is greater than V2, the charge will flow from V1 to V2 until a common potential is reached, correct? So let us derive what is common potential derivation. V is equal to Q by C, but Q itself is C1 V1 plus C2 V2, which is the sum of the two charges is getting added up by C1 plus C2, because here they connected in parallel. In the case of parallel connection, C1 plus C2. In the case of series is 1 by C1 plus 1 by C2 is the opposite of resistance. Okay, this is the common potential. Now what is the final energy is half CV square. So C1 plus C2 into V square is the common potential, C1 V1 plus C2 V2 the whole square by C1 plus C2 the whole square. This and this gets cancelled. So half of C1 V1 plus C2 V2 the whole square by C1 plus C2 is my final energy. So initial minus final energy. Initial energy is half C1 V1 square plus half C2 V2 square minus half C1 V1 plus C2 V2 the whole square by C1 plus C2. On taking LCM and expanding, half can be taken out, C1 square V1 square plus C1 C2 V1 square plus C1 C2 C2 C1 V2 square plus C2 square V2 square minus C1 square V1 square plus C minus C2 square V2 square minus 2 C1 C2 V1 V2 by C1 plus C2 on expanding and taking the negative signs inside. So this is C1 V1 square, C2 V2 square and C2 V2 square. So what's common is C1 C2 is common throughout. So what are you left with is V1 square plus V2 square minus 2 V1 V2 by C1 plus C2. Hence the formula is half C1 C2 by C1 plus C2 into V2 minus V1 the whole square, or V1 minus V2 the whole square. This will be the energy lost while sharing two capacitors.